For this problem, we're going to write a function given certain conditions. Here we want to write a function that's a rational function and has some asymptotes. We have a horizontal asymptote, y equal to 2, and we have a vertical asymptote, x equals 4. The domain of our rational function needs to be the set of all real numbers, such that x is not equal to 4 and x is not equal to 9. So we're going to start off by just kind of writing the general form for a rational function. Write our fraction bar. Because the domain excludes 4 and 9, we know we need a factor of x minus 4 in the denominator and a factor of x minus 9. That gets us our two restricted values. We see that we only have one vertical asymptote, x equals 4. It means 9 does not yield a vertical asymptote, so we must have a factor of x minus 9 in the numerator as well. We have a horizontal asymptote of 2. Since this is not 0 and it is a horizontal asymptote, that means the degree of the numerator and denominator need to be the same, and the ratio of the leading coefficients needs to be 2. We can put in a general factor, x minus a. That'll get us a degree 2 in the numerator, and right now the ratio of the leading coefficients is 1. To take care of that, we can put in another factor of 2 out in front, so our ratio of leading coefficients will be 2. The only restriction we want to put on this now is that a cannot equal 4. Because if it did, we would not get a vertical asymptote at 4. So we'll just write that out here, that x is not equal, a is not equal to 4. And there's a general rational function that meets the given conditions. We could get a particular rational function by letting a be some number that's not equal to 4. For instance, we could let a equal 1. If we let a equal 1, then our rational function would be r of x equal to 2 times x minus 9 times x minus 1 divided by x minus 4 times x minus 9. This satisfies all the given conditions, and it's one particular case. We can let a be any number except for 4, and we'd get a different particular rational function.